Howdy, welcome back to the shop. We're back on the Onan off camera. I took the governor balls and weights and all the goobly goop that's up inside of here. I took all of that stuff out and removed the fork and the shaft, took it out, and then I made a small plug that plugs the hole up where the shaft comes out. That's probably not 100% necessary, but I didn't feel good about having all of that stuff inside of this housing with no load against it. If it had exploded, bad things would happen. That's just things I don't want to think about. So anyway, that stuff, this has been emptied out of its treasures. Wonder where that came from. That's not something that you want to find just laying around anywhere. Strange thing is, I haven't taken a snap ring out of anything. So, after I got this done, through trial and error and cardboard aided drafting, I cobbled together this bracket. And it looks as rough on camera as it is in real life. So this bracket goes here, and that's what holds the mag pickup. So I'm going to get this bracket attached to the this housing, and then we'll talk about the MPU. So before any of yous ask, this flywheel, when I got this generator, this flywheel had two fins that had been broken off. They were laying down in the bottom of the housing, and the governor spring and adjustment on the outside was missing. I can only surmise that perhaps the governor spring had broke or something had come loose out here and had gotten into the flywheel. That's all I can think of, because there was no big bash marks on the housings or nothing. I don't know why two of the fins had broke off, but luckily there were 9 fins left in between the two that had broke off, and then there was 19 fins this way between them. So I counted down 9 from each way and busted one more off, and I don't know, it seemed more balanced than it was. So the mag pickup on this is a mag pickup. Now what this amounts to, this is a magnet, and inside of here is some hair. It's finer than cat hair, and there's about 17 miles of it up inside of here. It's wrapped around that coil, or wrapped around that magnet. And what this does is, as the flywheel teeth go past, it makes an AC electrical signal, and that signal is interpreted by the controller as speed. It's making, I don't know, somewhere in the high kilohertz to low gigahertz frequency, and it's looking for that frequency at about 3 volts that's how it knows how fast it's running. So that's all this is. I've got a little bit of grease on here, because I don't want this sucker to stick in the hole. You've just got 2 little old wrench flats on here, and that's all you got to get a hold of her with, and this little jam nut. So I'm going to blow, I've got some swarf from something or other stuck to the flywheel. I'm going to blow all of the dust off of this that I can get off of it, because every little piece of magnetic residue will get stuck to these stupid things. So I'll get this cleaned up and we'll stick her in hole. Yeah, on the old C-panel Generacs, and well, even the R panels and some of the newer ones, the ones that had the 2.4 Mitsubishis were pretty bad about, since it was a 4-cylinder, it only stopped in two places really. So you'd have 2 places on your ring gear that would get worn, and when the starter tried to engage, it would clash, and it just and give you all kinds of overcrank faults and stuff like that. But the really bad part about it was you could end up with a Oh, you could end up with crud. Now what I'm doing, I'm putting a tooth right underneath of this thing. I'm going to run her down until she touches. Now I'm going to back it off 3/4 of a turn. Let's see. Pointing about that direction. So I want to point her right about there. But that starter clash would put little fine shavings all over in here, and they'd get stuck to the end of the mag pickup, and you'd get, one day it'd be too much voltage and the next day it'd be too low. So good idea when you're doing a service on a generator to measure your mag pickup voltage and know what the value should be. On this one, 3 volts is pretty good. Anything from a 1/2 volt to 3 volts is good enough for these Barber Colemans, or Ching Chang Charlie Chan Barber Colemans. All right, I've shut the lights off in the shop and I've got the backlight on my fluke here. So I've got the fuel disconnected and the spark plugs out of it, so there's no way this thing will start because I don't have the cover over the flywheel, and bad things could happen if your arm got into that. So we're going to spin this thing over by the starter, and I've got her set to volts AC right now. And let's look and see what happens. That falls over. That's what happens. Oop. There we go. About 2 volts. Now we'll put her on frequency. $650 some hertz. So that was our frequency. We're getting some frequency, we're getting some voltage out of it. Our clearance is about 20 thousandths gap down there, so good enough for the girls we go with. So I think the next thing we need to do is hook up the governor linkage. So the next thing I need to do is figure out how much travel I need to go from, whoa, come back here, camera. Sorry, guys. So at idle position, we're about 3 1/4 inches. When we go to full throttle, we're up at 2 5/8. 3 1/4, 2 5/8. So I'm going to write that down so I don't forget it. 2 1/4, 3 oh, damn it. 3 1/4 and 2 5/8. Okay. So that amount of travel is fairly important because we want to get the travel of the actuator arm pretty close to matching this travel. As a matter of fact, if I could get that actuator arm, find a hole on that arm that is a 1/16 less travel, to where the actuator can't pull it all the way past hard into idle or run it all the way and jam wide open, that would be best. Because this is a 1/4 inch little steel shaft inside of a 50-year-old housing. It's got wear in it already. I don't want to wear it any faster than I have to, and I don't want that actuator to be jamming this thing wide open if it happens to react to a great big load. Like when I'm setting up the governor, I don't want it to react to a big load drop and jam it wide open and put extra tension. I mean, there is a throttle stop down here for wide open, but I don't want to use the throttle stop. I want to stop before it hits, if that makes any sense to anybody. I have actually seen a few of them that had set screws on the bracket that held the arms to stop over traveling. That was you really seen that a lot on the old mechanically driven, belt driven governors. Woodward made some of those too. So we'll get some measurements down here on the actuator arm and go from there. So with my actuator arm put on backward, but more or less in a horizontal position. Well, you can't see that worth a hoot. And a flashlight in the way of the camera. Anyway, take my word for it, that's about 9 1/4 there and about 8 1/2 there. So that gives us 3/4 of an inch of travel. So I needed 5/8, I've got 3/4. I've got plenty of travel. I wish I had a little bit less, but it is what it is. That's the furthest in hole, so it is what it is. So next thing I need to do is decide where to poke a hole through for my rod to come up through. All right, through some wild guesses and interpretive dance, I figured that ratchet hit me in the foot doesn't feel very good. There's pert near the end of our, or the pivot of our arm will be straight down underneath this. So the pivot for the carburetor arm, bell crank, whatever you want to call it, is going to be right about there. Something like that. Which kind of looks right, being there's that linkage is hanging straight down, so we know that our hole will be in between this mark and the back. Makes sense to me. So I'm going to guess about halfway in between the two of them and just drill a hole and see what happens. And I'm just going to kind of eyeball it. Somewhere right about there, I think, is where our hole needs to be. So along this line, between this line and between the back, somewhere in there. So let's see, this has went 13 minutes. That's kind of unlucky, even on April Fool's Day. So I think I'm going to cut the video here. You get the idea. It's just going to be drill and whittle and hack and drill and whittle and hack. And I'll get a linkage made up. And in the next video, we'll put the linkage in, get it roughly adjusted, and do a little wiring. Till we meet again, y'all drive safe and watch for deer. Poor old ratchet.